Hello, everybody. Welcome to the Frontiers in Science deep dive webinar. This one is on safeguarding the polar regions from dangerous geoengineering, a critical assessment of proposed and future prospects. So, my name is Laure Sonnier, and I am the executive editor of Frontiers in Science. And today's webinar presents the Frontiers in Science lead article led by Professor Martin Siegert and colleagues on the technical feasibility, long-term cost, environmental risk, and governance limitations of 5 approaches to deploying polar geoengineering as a climate mitigation strategy. As the lead article and the article hub was published 2 weeks ago, and what an impact this article has had in just 2 weeks since publication. It's been picked up widely by global media, from the Scientific American, CNN, Bloomberg in North America, to BBC, The Telegraph in the UK, as well as Le Monde in France in Europe, ABC News, and the Straits Times in the Asia Pacific region. So overall, to date, 304 coverage items so far, and with more still to come. So massive attention in the world on this paper and its related content. So before diving into the symposium, I would like to thank deeply Professor Martin Siegert, Dr. Valérie Masson-Delmotte, and also Professor Steven Chown, who are all here with us today. And I'd like to thank them for bringing this important research to Frontiers in Science. We couldn't be prouder to give this article and its related content home in Frontiers in Science. So before we actually meet all these authors and our guest experts, I'd like to give you a few words about Frontiers in Science. For the newcomers to this deep dive series, Frontiers in Science, the scientific journal where the lead article was published, is our flagship multidisciplinary open access journal at Frontiers. And the focus of the journal is really on transformational science, key to accelerating solutions to global human and planetary health challenges. We in this very journal, the way we operate is by commissioning exceptional peer-reviewed lead articles from exceptional world-leading researchers. And then around each of these lead articles, we built a unique hub of multi-audience content. In this multi-audience hub, we have scientific viewpoints, editorials, policy articles, and also content actually for kids and also the general public. And then we work to provide massive visibility to all this content by maximizing the dissemination via large-scale communication campaigns. And really, the whole program is designed to extend the journal's reach and impact across science, policy, and society audience. So that really exceptional, transformational open science can reach everyone. And this is really all designed to extend the journal reach and impact. And to date, we have published 23 hubs spanning 88 articles, covering a diverse spectrum of transformational science. This science globally has been viewed over 2 million times and downloaded over 300,000 times, and even cited over 850 times, and is regularly picked up, as you've seen, in top media. So this is really, we launched the journal 2.5 years ago, and this is really a testimony of the broad impact Frontiers in Science is already having in the scientific community and beyond. And just to close, I would like to say that we are really delighted to be driving innovation in this respect in publishing. so that this type of like critical transformational science, open science, as the one we will be discussing today, can really reach everyone and accelerate scientific progress for all. So today's discussion is going to be moderated by my dear colleague Nina Hull, who is the managing editor of Frontiers in Science. And I'm delighted now to hand over to you, Nina. Thank you all. Enjoy the event.
Thank you very much, Laure. And hello and ni hao from Switzerland. It is late morning here, but we expect to have an audience from over 58 countries joining us today. So good morning, good afternoon, and good evening to all of you. And thank you very much for being here. We're thrilled about it. As Laure mentioned, today we're focusing on a very hot topic, the Frontiers in Science lead article on safeguarding the polar regions from dangerous geoengineering, a critical assessment of proposed concepts and future prospects, published earlier this month. Here you can now see the full article. And as we all know, the burning of fossil fuels continues to warm our planet, and Antarctica and the Arctic specifically are heating far faster than the global average. And of course, this rapid change has severe consequences, both locally but also globally, and already affecting fragile local communities and ecosystems through the loss of sea ice, glaciers, and ice shelves. And because decarbonization is proceeding slowly, temperatures keep rising. And because the polar regions play such a vital role in regulating Earth's climate, some scientists and engineers have put forward technological interventions, collectively called geoengineering, to try to help reduce the impacts of this warming. So in today's Frontiers in Science lead article, the authors, 42 top polar scientists, critically assess 5 of these geoengineering ideas proposed specifically for the Arctic and Antarctica. And those are what we will be exploring together today. Here you should now be able to see the rest of the hub, which includes also an editorial by Professor Mike Halm from the University of Cambridge in the UK. We have 2 viewpoint articles, one by Professor Frans Berkut from King's College London, UK, and Professor John Moore from the University of Lapland and colleagues. And freshly published this morning, we have 2 excellent policy outlooks, one by Sophie Crump of the Inuit Circumpolar Council in Kalallit Nunat, Greenland, and by Professor Aarti Gupta from Wageningen University in the Netherlands. And both authors will also join us later in our panel discussion. And along with all the scientific content and what Laure has already explained, you can also find a lay explainer, infographics, a video, as well as an article in Frontiers for Young Minds. It's our beloved kids journal, so please do take a look. But for now, let me actually start going through the program for today's deep dive. Firstly, we have Professor Martin Siegert, the lead author, who will set the scene for today's discussion. Dr. Valérie Masson-Delmotte will follow on from Martin to dive deeper into stratospheric aerosol injection and ocean fertilization. Continuing from Valérie, Professor Steven Chown is going to discuss sea curtains and glass beads, before handing back to Martin, who will wrap up the presentations discussing sea ice thickening and slowing sea ice. As I've mentioned, we will then have a panel discussion, and we'll have 2 additional guests, our policy outlook authors, who will join us at that stage, Sophie Crump and Professor Aarti Gupta. Right, but now let's get started properly. First up, I'm delighted to welcome Martin Siegert, Vice President and Deputy Vice Chancellor of the University of Exeter in the UK. As many of you will know, Martin is an internationally renowned glaciologist, recognized for his pioneering research on Antarctic ice sheets, subglacial environments, and their role in Earth's climate. Previously co-director of the Grantham Institute at Imperial College London, Martin was very much the driving force behind climate and environment-related research, translating it into into real world impact and communicating it widely to actually help decision making. In his current role at the University of Exeter, Martin is responsible for advancing the university's and the wider region's ambitious 2030 net zero goals. Martin, thank you very much for bringing this important work to Frontiers in Science and for joining us today, and the floor is yours.
Thank you, Nina, and good morning, everybody, from lovely, beautiful, sunny Cornwall, where I am. I'm at the University of Exeter, and I'm responsible for our work in Cornwall. I'm pleased to be here to tell you a little bit about our paper. So, hopefully you would have seen the paper, but it's available online, completely free, of course, to access. But it's fair to say that we all understand that the polar regions are warming at an accelerated rate as a consequence of burning fossil fuel. In the Arctic, something like 3 to 4 times the rate of the rest of the planet, and in the Antarctic, around 2 times as well. So it's alarming, and we should be deeply concerned about it. In the polar regions, they have particular governance and sovereignty arrangements, and very different in the Arctic, which has sovereignty rights, of course, as opposed to the Antarctic, which is overseen and governed through the Antarctic Treaty System. More on that a bit later. In the Arctic, of course, is the home to indigenous peoples whose rights, ways of life and protections need to be fully considered in our understanding of the polar regions in the Arctic into the future. We should also understand that the polar regions are extreme environments. They are pristine and they're vulnerable wildernesses as well. They really do need our protection. We should also understand that doing any work in the polar regions is really challenging to do. Often you see pictures of the Arctic and Antarctic and it's lovely and sunny. That's often not the case. You know, you do get extreme conditions in these places, and doing even simple things becomes a real challenge. We should understand also that the Arctic and Antarctic are fragile environments. They are unique, but they're vulnerable and they're fragile systems. And if we disturb them forever. We should also understand that in the Greenland ice sheet and in the Antarctic ice sheet, there's huge volumes of frozen water, ice, that's above the level of the ocean, that if it melted or flows into the ocean, sea level goes up, which is a potentially catastrophic issue for our world. And also, we should also fully understand that in many senses, the polar regions are still unexplored. We know so little about what's going on in the major ice sheets in Greenland and in Antarctica, and in indeed the Arctic Ocean basin and the oceans surrounding Antarctica as well. And I think this is something that's extremely important when we start to consider ideas and concepts to manipulate the polar environments in some ways, that we still really do need basic research to fully understand the processes that operate in these places. And as I said, doing anything in Antarctica or the Arctic is challenging to do. It requires significant logistics and logistics chains to get equipment, people, fuel from into deep field remote locations. And it needs time as well, time in terms of building up a program. Someone once said to me some time ago that it takes at least 10 years in Antarctica to get a project together. And when I was younger, I didn't really think that was 10 years felt infinite to me, but now I fully understand that that is definitely the case. And there's also examples of how that's true. But even when it happens, doing things in Antarctica requires a human presence that is unusual for these environments, and we do have to consider those things as well. So we looked at a number of different geoengineering ideas, and you'll be familiar, I should think, with some of them that have been talked about. We wanted to assess them critically with regard to a set of criteria that we think can help us understand whether they are viable or not. And indeed, even in the concepts that we don't cover in our paper, the criteria are probably still relevant to any idea of climate intervention, manipulation, or call it what you will. And these are as follows. They are is it actually going to work? Scientific feasibility of doing it. Would there be environmental risk? Do you cause any damage in the process by which you try to achieve that work? How much will it cost? And often these ideas will cost an awful lot of money, many billions of US dollars. And where is that going to come from? Recognizing the governance challenges of this as well. So who does oversee the work to ensure that it's done in an appropriate way with respect to the governance arrangements in both the Arctic and Antarctic being different, as I said previously. But scale and time constraints, we need to think about the climate problem on our planet, which is severe, and we need to find solutions to it rapidly. Do these ideas work in terms of the scale and the vast area of the Arctic and the Antarctic, and in the time that we really do need to tackle this problem? And even though I wouldn't say that proponents of climate interventions, certainly the ones that we've assessed here, would be thinking this way, if you were minded to continue to receive lots of money from burning fossil fuels, are these ideas a bit of a gift to those people that offer the sort of pretense of a climate solution without there being one? And I think that's something we do need to take a look at as well. So I'm going to hand over back to Nina and take it further from here. Thank you, Nina.
Thank you very much, Martin, for starting us off today and giving us this introduction. We're moving on to our next speaker. That's Valérie Masson-Delmotte from the Institut Pierre-Simon Laplace in France. Valérie is, of course, one of the world's leading experts on past and present climate change. Her research has been critical for testing climate models and for highlighting the vulnerability, particularly of the Arctic and Antarctic, to global warming. As co-chair of Working Group 1 of the IPCC, she helped coordinate the global scientific consensus on climate change, including the 2018 special report on global warming of 1.5 degrees Celsius. Valérie was recently elected a member of the French Academy of Sciences, being recognized for her work on climate change and commitment to supporting research and science diplomacy. So Valérie, welcome, and thank you very much for being here with us today. The floor is yours.
Thank you very much, and greetings from rainy Paris-Saclay today. So I'm going to dive into the first of the concepts where we have applied our analysis framework of the multiple dimensions of feasibility, risks, and governance. And so this first concept is stratospheric aerosol injections. As you know, it's one proposed method of solar radiation modification, an intentional modification of the Earth's radiative budget to offset some of the effects of increasing greenhouse gas concentrations, but without acting on greenhouse gases themselves. And the concept is inspired by the cooling effect of aerosols injected by volcanic eruptions. It requires the injection of different types of aerosols in the high atmosphere, which includes the injection of sulfur dioxide or sulfate aerosols, which are pollutants. The last IPCC assessment report in 2021 highlighted large uncertainties in effectiveness. And you know that this type of approach could be associated with a termination shock, the risk of abrupt climate adjustment if such methods are deployed without reducing greenhouse gas emissions and stopped. And an implication is the timescale of committed deployment, which would require multi-decadal prolonged or permanent injection. In this study, we have focused on the specific deployments to have an impact in polar regions, which are characterized by lower insolation, polar night, and higher albedo. And of course, such approaches would be completely ineffective for polar regions in winter during polar night. There would be specific and larger uncertainties for polar regions where the local polar atmospheric circulation induces a rapid removal of aerosols, leading to a shorter lifetime of these aerosols and more localized cooling effects. It would have very limited effect on preventing ocean-driven glacial melt. We have also looked at the potential negative consequences, which include residual warming in winter, stratospheric heating, which could affect ozone depletion. And such a methodology would not address or could exacerbate ocean acidification, which is a major risk for polar marine shelled animals and economically important species that depend on them, such as krill or cod. Moreover, the deployment in one polar region, by acting on the differential cooling of one atmosphere, could disrupt the intertropical convergence zone and affect climate patterns. We have also looked at aspects related to costs, because such approaches would require lofting hundreds of thousands of millions of tons of material each year to altitudes up to 20 kilometers. So it would require a fleet of specific aircraft. And several of the studies in the literature clearly oversimplify financial realities. There would be requirements for costs in capital and operations, but also costs to monitor and measure the impacts. The scientific literature shows the potential for unforeseen impacts through effects on weather patterns, water, energy, health, and food production. So one dimension specific to this approach would be the liability, the legal challenges, and the costs related to adverse impacts. We also highlight that while some studies have framed solar radiation modification as a potential means to delay the crossing of potential tipping points, others have indicated it is less effective than the reduction of greenhouse gas emissions due to the uncertainties and risks involved. And the studies rely on simplified scenarios that neglect socio-political factors that could cause harm or raise ethical dilemmas. And a core aspect related to this approach is the absence of governments. There's no enforceable framework that currently exists. Such approaches could be used as a disruptive tool in a wider geopolitical context, and the risks of unilateral developments could increase geopolitical tensions. So we highlight the lack of any international agreement preventing countries from using such strategies that could negatively impact other countries. And these approaches are raising ethical considerations of deliberately altering the climate using direct pollutants. I'm now going to move to another approach. So the second concept that has been scrutinized in our objective framework of feasibility, risks, and governance. And the second concept is ocean fertilization. So this concept builds on the role of the ocean as a CO2 sink. So it's a form of geoengineering where nutrients whose availability limits phytoplankton growth, such as iron, are added to the ocean surface water to promote photosynthesis and stimulate blooms, with the goal to increase the drawdown of CO2 from the atmosphere, which is then expected to sink to the deep ocean for long-term storage. A prime target area for such deployments is the Southern Ocean, where low iron availability limits phytoplankton productivity. So far, there have been 19 experiments, including 12 in the Southern Ocean, and outcomes have been inconclusive. We have to highlight that the monitoring of such experiments has been pursued on the short term, only a few weeks. We understand well that there would be negative consequences. Such approaches could trigger complex effects amongst a complex mix of hundreds of species, which respond to physical and biological controls, and which are unknown and unpredictable. It could restructure plankton communities at the base of the food web, which would affect the dynamics in the Antarctic marine ecosystem and beyond. We have also a good understanding of what could be unintended consequences. The trapping of nutrients, the deoxygenation and production of other greenhouse gases such as methane or nitrous oxide, as well as the potential effects of nutrients transported in other regions. So a consequence framed as nutrient robbing. And such effects mediated through ocean circulation could affect productivity and important fisheries, for instance, in the tropical Pacific and communities that depend on these fisheries. When looking at the other dimensions of our assessment, we highlight that a full-scale deployment would require considerable efforts and resources, including an armada of ships and the supply of suitable material. This objective analysis shows a clear difficulty of scaling up for commercial applications and a very high cost, more than $1,000 per ton in offshore areas. Finally, such approaches raise a number of governance challenges, including the legality of adding iron, a pollutant, to the ocean, while such approaches are regulated by the London Convention, and therefore no large scale could be implemented. Such approaches are not allowed for carbon credits in the current UN Framework Convention on Climate Change. It's not addressed by the UN Convention of the Law of the Sea, but could fall under the definition of marine pollution. It's not considered in the Antarctic Treaty System. And in fact, it's raising similar issues as aerosol injections in the stratosphere, the use of direct pollutants, and the effects in other regions through ocean and atmosphere circulation. With that, I would like to thank you, Nina, and pass over for the other concepts that have been scrutinized.
Thank you very much, Valérie, for that deep dive into SAI and ocean fertilization. Before I hand over to our next speaker, just a quick reminder for all of you watching, if you have questions you'd like me to put to today's guests later on, please to add them into the Q&A tab. I can see lots of questions already also happening in the chat, but the Q&A tab we'll go there first, we'll pick them up quicker. Right, next, it's my great pleasure to introduce Steven Chown, an award-winning biologist and one of the world's most highly cited researchers in Antarctic environmental science and policy. Steven brings more than 30 years of fieldwork in Antarctica and has also worked extensively across Australia, the Indo-Pacific, the UK and South Africa. He's the former head of the School of Biological Sciences at Monash University in Australia and was the founding director of the Centre of Excellence for Invasion Biology at Stellenbosch University in South Africa. Steven's pioneering research addresses large-scale environmental change, which we are discussing here, and the strategies needed for mitigation and adaptation for both regional and local levels. Steven, thank you very much for joining us today, this evening, all the way from Australia, and the floor is yours.
Thank you, Nina. It's a pleasure to be with you here tonight in this important forum. I'll continue with the specifics as Valérie had started, and in particular, I'll deal with two. The first is sea curtains, and the second is glass beads. In each case, these polar geoengineering concepts apply both to the Antarctic and the Arctic, but I'll focus for sea curtains on the Antarctic and then switch the focus for glass beads and the reflection of sunlight on the Arctic. So for those of you who don't spend much time thinking about the Antarctic ice sheet, it's an enormous ice sheet. At its deepest point, it's 4 kilometers thick, on average about 2 kilometers thick. It contains more or less 58 meters of sea level rise. And one of the proposals is that as the ice from the ice sheets extends into the ocean, it forms ice shelves, and these buttress the ice sheet. They keep it on land so that it's not having this effect on sea level rise. And one of the proposals is to prevent warm water from reaching underneath the ice shelves, as is already starting to happen, and also to prevent warm water from reaching grounding lines, the place where the ice meets the ocean and the bed, and if water gets over that, because these ice sheets often have deep marine troughs below them, that would accelerate, of course, the movement of the ice sheet into the ocean. So the approach is to install a sea curtain at 700 to 1,000 meters depth, with a curtain rising between 150 and 500 meters, essentially to block the warm water from moving underneath the ice shelf. For those of you who have not been to the Antarctic, you may not realize that these environments are incredibly difficult to work in. One has to understand the seabed to ensure that this works. These structures preferably have to be on hard rock, and there's sediment in many places. In turn, there's loading on the seabed, which causes significant difficulties. And either they would have to be constructed in situ in these areas, bearing in mind that there are large icebergs from the ice shelves breaking up, and of course seasonal sea ice, or they'd have to be constructed elsewhere and then towed into the region by ships that are essentially class A1 strength icebreakers, so they are resistant to damage from ice. So even if one was able to make such a deployment, of course, there's also the question of if the warm water is diverted from one ice shelf area, the likelihood is that it would flow to another ice shelf area, causing problems elsewhere. So that's one of the first concerns with sea curtains. The second is that one has to have a positive mass balance too. So you have to, of course, also have snowfall or artificial snowfall on the surface of the ice itself. If you think about the difficulties of deployment in the area, ships have been trying to work in the Thwaites Glacier area for a long time now, for 40 years or more. And if you simply look at the track record of research expeditions, which by comparison are quite straightforward, then about 56% have been subject to partial disruption, 22% have failed entirely. And in the Inner Bay curtain site proposed for Thwaites Glacier, one expedition has made it in 40 years. So these are quite significant structural challenges. If they were installed, the sea curtains would be enormously disrupted to flow. That would change productivity in the area, especially flow that has iron coming in. It would have impacts on the marine system. For those who are not aware, these are some of the most diverse seafloor systems. And of course, there's plenty of wildlife that potentially would be affected too, as we know that wildlife is affected by various kinds of barriers. In addition, if one were to construct these sea curtains elsewhere and tow them in, there's an enormous problem of raising the risk of the introduction of non-indigenous species, which may then become invasive. And of course, there's some groups that are absent from the Antarctic for a variety of reasons, and if brought in, could be quite damaging. If we think simply of costs, one of the analyses we make in the paper is to indicate that the relatively straightforward construction of the Thames Barrier right next to London, with none of these major challenges, was about 6 times the cost that's been estimated currently for these in the Antarctic. And the Three Gorges Dam, which technically is perhaps a little more equivalent, but still in a relatively accessible area, was 25 times the cost. Of course, in the Antarctic, the Antarctic Treaty System, and specifically the Antarctic Treaty and its protocol on environmental protection, require that all such installations, any developments in the Antarctic, are subject to an environmental impact assessment. And of course, you need a comprehensive one if the impact is expected to be more than minor or transitory. And these, of course, would immediately qualify for more than minor or transitory. That's a complicated process, and given the response of other areas, even simple stations take years to get through the system, the expectation is that there would be significant delays with the impact assessment process itself, in theory. And in practice, at the 47th meeting of the Antarctic Treaty Consultative Parties, their Committee for Environmental Protection suggested that they are simply not going to approve polar geoengineering strategies. The second area that is worth talking to here is, of course, thinking through in the Arctic the effect of raising the albedo. In other words, increasing reflectivity. A reflective ocean surface means that the ocean's not warming. And of course, if the ice disappears, the sea ice in this case, then warming takes place. And the proposal is to distribute borosilicate or glass spheres on the ocean surface to increase the reflectivity. There are a few problems with this. One, the scale is enormous. It amounts to 360 megatons per year of glass beads. The shipping is not available to undertake it. One study has already been ceased as a consequence of ecotoxicological problems, and the ecotoxicology is starting to be understood for invertebrates, but there's no real idea for vertebrates at the moment. And of course, these oceans are undersaturated in the Arctic for silica, and the introduction of borosilicate beads that are then soluble means that you're changing the productivity dynamics of the region. So this particular geoengineering concept does not meet the criteria we set out either. And with that, back to you, Nina.
Thank you very much, Stephen, for introducing us to the risks and issues associated with sea curtains and glass beads. And I'll swiftly go back to you, Martin, now for the last presentation.
Yeah, thank you, Nina. So we looked at a couple of other concepts as well on sea ice thickening. So people might remember earlier this year, at the end of the austral summer, the world had less sea ice in it than at any time that it's been measured previously. And of course, that white reflecting surface bounces solar radiation back out into space. And if it's not there, the solar radiation gets absorbed into the ocean. And so is a major driver of polar amplification of global warming, of course. In particular, in the Arctic, where the sea ice levels wax and wane from somewhere around 15 million square kilometers down to something like 5 million square kilometers every year. That 10 million square kilometers is important because that's the loss or gain of the sea ice that can act as a reflecting surface. And of course, it's not necessarily at the end of the season where this matters the most. It's during the summertime when the sun is high in the sky and the reflection or absorption would be greatest. And so it's tempting to see and think about how we can thicken up the sea ice to prevent its loss, that 10 million square kilometers of loss, and slow it down over that time, especially when the sun is high in the sky, and therefore increase reflectivity and decrease absorption. So that's the sort of concept behind it. Of course, the scale is the problem, the major problem with sea ice thickening in the Arctic. That 10 million square kilometers is an enormous area that would need to be covered. Just for reference, the surface area of the United Kingdom is about 280,000 square kilometers. And so 10 million square kilometers is absolutely enormous. I really don't think it's practical or reasonable to consider any idea of sea ice thickening at that scale over the coming decades. There's no real implementation plan that I can see that would really work. But even if you could do that, the human presence that would be needed, the number of devices that would be needed would be staggeringly large and would change humans in the Arctic considerably, maybe very different to what they are at the moment. The costs would be considerable as well, and there's no real idea about where it's going to come to. And of course, there's governance issues related to sovereignty boundaries as well. So how would that happen? There are some issues with the sort of chemical alteration of the sea ice. Sea ice has a particular way of forming itself quite slowly over a season. And by taking, say, seawater and either flowing it directly onto the surface or pushing it into the air and letting it fall as snow, that would be a very different chemical composition to the ice that's underneath it. And of course, it may have different structural properties as well, which are important in sea ice considerations. But the major problem with this, of course, is that 10 million square kilometers of sea ice. And is there any feasible way of thinking about protecting that through this process over coming decades where we know we've got to act. On the next one, we talked about slowing the ice in Antarctica as well. So this is, again, a concept which is understanding that as ice flows into the ocean, either through acceleration because of the loss of the back force from an ice shelf, or just to slow it down generally, both will help alleviate sea level rise as a concept. So that's understandable. The problem with this is that what you would need to do is to remove basal water from the ice sheet and the fast flowing ice streams in particular. And to do that, you would need to drill down into the ice sheet, access the subglacial aqueous environment, and pour that water up to the surface, manage it somehow on the surface. And if you did that successfully, there's a potential that you would increase the friction of the ice at the bottom and slow it down. But there are a number of problems that we think just sort of prevents this idea from taking place. Firstly, around our knowledge of subglacial Antarctica, which is something that I've been studying for about 30 or so years. And although it's definitely improved, it's also definitely the case that we don't know enough about the subglacial environment to really understand where you would drill, how many boreholes you would need to do, and what the consequences of those things would be. In fact, I organized an international meeting earlier this year on understanding subglacial environments and bed measurements in Antarctica primarily, although the same is true in Greenland, with the sort of prime objective of using that knowledge, that improved knowledge, and putting it into ice sheet models to make them more, increase their prognostic abilities to understand changes. At the moment, you know, our knowledge of subglacial Antarctica is pretty sparse. And there are things that we really don't know as well, like the presence of groundwater. It's almost certainly the case, well, it's definitely the case, that the ice sheet bed is not an impermeable layer. And so underneath that, there will be groundwater will exist in Antarctica, but we've really got very little idea about the size and shape and presence of it. But it's quite possible that it is significant, in which case it will mean drawing up water from the subglacial system, a rather futile experiment because it will simply be replaced by potentially a very large store of groundwater. We know that paleo ice sheets that existed in the Ice Age 20,000 years ago did have groundwater influences, so it's reasonable to assume Antarctica would do as well. But then you go to just the concept of drilling in Antarctica, and this is something that I've got direct experience of. Drilling even a single hole in Antarctica is really difficult. It needs megawatts of power, and it needs quite a lot of people there just to do one hole. But we've never extracted water from the bottom of the ice sheet in any sort of voluminous way at all. And that's because it would be really, really difficult to do. If you can't, the water borehole you make will have to be full of water, of course, and the ice around it is really, really cold. And so that borehole will simply freeze up, probably within some hours, a matter of hours, unless you case the hole with a lining and unless you heat the hole to keep it warm. But we've never done that in Antarctica, and the kind of cost and the power constraints would go up considerably if you did it. If you did successfully hit an aquifer or a channel, a water channel or something like that, these ice streams are moving quite quickly. And so possibly in a matter of hours, certainly in a matter of days, the bed of the ice sheet would have moved off somewhere else. And so it'd be really difficult to see how it would be able to be kept going for any length of time, which would mean you need many, many holes to do this job, which would be a tremendous cost. The final thing to say about this is the subglacial environment in Antarctica is possibly one of the last truly pristine ecosystems that exists on our planet. The BBC Radio 4 are doing a program on it. It's called In Search of No Man's Land, and you can check it out on the BBC iPlayer if you have access to it. And it's trying to find a place on the planet that is completely untouched by human presence. And I think possibly one of the few places where that is true will be subglacial Antarctica. Of course, this project will be aiming to really interfere with that pristine system and pour water up in a sort of voluminous way and discard it onto the ice surface. And I think there will be all sorts of governance challenges, especially regarding the Antarctic protocol on environmental protection that Stephen mentioned earlier, which really makes the signatories of the protocol aligned with ensuring that Antarctica's environment is protected in a comprehensive way. So, as you can see, we've been through a number of concepts, and we've judged them on a number of different things in terms of their feasibility, the environmental risks that would happen. We look at the financial costs, the governance challenges, the scale and time constraints to actually make a difference, and of course, the idea of full scopes, as I said at the beginning. Even though we've judged the various concepts that we talked about today, I think this list of criteria would stand for any sort of climate intervention idea. And it might well be that out there are some that meet these things. I mean, possibly sort of direct air capture, although scaling that's going to be quite difficult. Nature-based solutions and things like that will be, would meet these things. But I do think we have to be very careful about promoting ideas that don't meet any of these criteria, or even one or two of these criteria, because it would surely prevent them from being realistically plausible within the time that we have to solve this problem. So how do we solve this issue of polar protection? Well, definitely we need to decarbonize. And of course, we've been working on decarbonizing for several decades now. There is intergovernmental support for understanding climate change, no matter what Donald Trump said yesterday at the UN summit, of course. But there's international scientific consensus on this, and there's great progress that's being made, maybe not quickly enough, but lots and lots of things have been happening. We need to go further, we need to go quicker, but so much has been done already, and distracting us away from that is a real danger, I think. We can also consider how the benefit of marine protected areas into the Arctic and Antarctic, some of which already exists, but really pleased that high seas treaties seem to be being supported now, which is great news for protecting the marine environments. And on land, Antarctica, especially protected areas, gives another level of protection to ensure that we consider the Antarctic as a special, pristine, vulnerable place that needs our protection. And if we change it, it's changed forever. And we really do need to think about these things for ideas going forward. And I'm going to hand you back now to Nina. Thank you, Nina.
Thank you very much, Martin. Thank you. And we've now wrapped up our presentation, and it's high time we move to our panel discussion. Please keep your questions coming, and I'll put as many as I can to our guests. Talking of whom, I'm now delighted to welcome our two policy outlook authors who will be joining Martin, Valérie, and Stephen for our Q&A. Firstly, I'd like to introduce Sophie Crump of the Inuit Circumpolar Council in Kalaallit, Nunaat, Greenland. Sophie has more than a decade of experience in grassroots research, education, and capacity building, including years of working with Arctic indigenous communities to advance indigenous-led environmental monitoring, research, and guardians programs. At the Inuit Circumpolar Council, she supports Inuit leadership in advocating for the rights of indigenous people and the recognition of indigenous knowledge in international forums, such as the UNFCCC, the Convention on Biological Diversity, and the Arctic Council. Our final guest is Aarti Gupta, Professor of Global Environmental Governance at Wageningen University in the Netherlands. Aarti is a key voice within global climate policy, and her research examines transparency, accountability, and equity in global climate and environmental governance, as well as the anticipatory governance of novel technologies, such as modern biotech and solar engineering. So a warm welcome to both of you. Thank you for joining us today. And I'm going to throw you right into the water now, Sophia. Let's start with you. Your policy outlook frames the Arctic as a region where indigenous rights, leadership, and knowledge must be foundational to any discussions of climate policy. Given that the Inuit homelands span across multiple nation states, could you elaborate on why applying a rights-based perspective is essential for guiding decision-making on climate action across the Arctic. And why must this be applied consistently, not just for novel polar geoengineering ideas, but also to mitigation efforts such as decarbonization pathways or a just energy transition. The floor is yours, Sophie. Go ahead.
Good enough, Nina. Yeah, thank you for the opportunity to contribute to this panel. It's very helpful to have an overview of some of the concerns around the science related to these geoengineering projects. Yeah, I think to start with, maybe I can just underscore that Inuit have an interconnected and interreliant relationship with the lands, waters, and ice of their homelands. And across the Arctic, almost all of the Arctic are indigenous homelands, not just to Inuit, but to many other indigenous peoples as well. And as the impacts of climate change are being felt more and more around the rest of the world, Inuit and other Arctic indigenous peoples have been feeling this for decades, and Inuit in particular have been ringing the alarm bell for decades, advocating strongly for climate action and offering their knowledge and expertise also to addressing climate change. I think when we talk about climate action, often there's a call to act for the sake of the global greater good, which is true and which is necessary, but it often underrepresents that there are actually also people who live in and depend on these environments. And so today, Inuit living in the Arctic are experiencing changes that undermine their built infrastructure. Sewers and roads are disappearing as the permafrost thaws, and entire communities are facing relocation. The unpredictable freeze and thaw of sea ice makes hunting and fishing unsafe and threatens food security. And so we know that that climate action is critical, but it can't be pursued at a cost to the rights of Indigenous peoples. A rights-based approach is essential because Inuit and all Indigenous peoples are not just an interest group. They're not a potentially affected population. They're not one on a list of vulnerable populations, as we often see them included in UN documents. They're not stakeholders either. Inuit are rights holders, and that means that they have to be engaged as equals in a decision-making process. So it's not just about hearing what Inuit have to say and consulting with them, but fully engaging in making a decision together. The collective and individual rights of Indigenous peoples are inherent, and they stand regardless of whether states recognize them. They are enshrined in the UN Declaration on the Rights of Indigenous Peoples, but they existed before that declaration articulated them, and they continue to exist outside of that declaration as well. And these rights are not just something for states to pay attention to. They are relevant for research activities, for policy development, for resource extraction, for all activities carried out on Indigenous homelands. And this includes the right to self-determination as a prerequisite for the enjoyment of all other rights, the right to provide free, prior, and informed consent, which is a right to say yes, or yes with conditions, or no to projects. It is a right to be fully informed and a right to exercise decision-making without financial, political, or other forms of pressure. The rights of Indigenous peoples also include the right to participate in decision-making on matters that affect their rights, around the use of their land, territories, and resources, including developing them and protecting them. So on both sides of this discussion. And so Indigenous peoples have to be engaged in all aspects of decision-making about climate action, the governance and the research and the policy making. And this includes the novel geoengineering projects we're hearing about, but it also includes decarbonization strategies like the energy transition, establishing and managing protected areas, and other solutions that would be identified also through Indigenous knowledge and ways of life.
Right. Thank you, Sophie. Thank you so much. And I'm sure we'll come back to quite a few of the points you've made during the Q&A. I'll go on and ask Aarti now to actually talk a bit about her policy outlook. It confirms, you confirm that influential global bodies and governments are rejecting solar engineering, leading the call for an international non-use agreement. This movement, restrictive movement, is described as being advanced by political leadership emanating from the global south. Could you maybe elaborate on the dual nature of this growing opposition? Specifically, what are the central components of the movement, and what is driving this decisive rejection from academics, civil society, and particularly from the countries that are most vulnerable to climate change?
Yes, thank you very much. Thank you, Nina, and thank you to Frontiers in Science for this invitation and for including me in this important conversation. So in my policy outlook, I discuss both the scientific and the political voices that are highlighting the many dangers of solar geoengineering, very articulately presented right now. We've heard about them for the polar regions. And specifically, I highlight in this outlook the growing call for non-use of solar geoengineering, that is prohibiting technology development and its potential future use. And the most striking political development here is the African Ministerial Conference on the Environment, the AMCEN. It's a biannual meeting of African environmental ministers, which took place this July 2025. A set of decisions emanating from this meeting, these decisions explicitly and resoundingly reject solar geoengineering as having any role to play in addressing climate change, given significant, as they put it, significant environmental, ethical, and geopolitical risks posed by these speculative technologies. And African countries are not alone in calling for non-use. This position has been supported in various other UN fora by countries like Vanuatu and other Pacific Island states. And so in essence, what I point out in this policy outlook is that almost 60 countries of the global south, and some of those most vulnerable to climate change, are now speaking out strongly and clearly against solar geoengineering. And this is mirrored also in the growing number of academics calling for non-use. So I'm a co-initiator and a signatory of an open letter, an academic open letter that was launched in 2020. And this open letter calls on political actors, on governments, on the United Nations, on other actors to commit to 5 elements of non-use. So what we call for here, call on governments and others to do, is not deploy solar geoengineering technologies, not allocate public funding for research that leads to technology development, not allow outdoor experiments on their territories, not to grant patent rights to these technologies, and not to support solar geoengineering as a policy option in international institutions. And I just want to note that this open call has now been signed by close to 600 academics from all over the globe, from all disciplines, and has also been endorsed by more than 2,000 civil society organizations with memberships worldwide. So let me just end, Nina, with the 3 fundamental reasons why we call for non-use, many of which resonate with what we have just heard from the presentations. The first reason are the severe, unknowable, unpredictable, unequally distributed future risks of any use of solar geoengineering. And here we call in our open letter, specifically, we are focusing on SAI, most importantly, stratospheric aerosol injection. The second reason is the implausibility of any sustained, effective, and inclusive global governance of any such multi-decadal planetary interventions in our divided, geopolitically tense world. And the third reason is the risk of distracting ourselves from the ambitious mitigation we need to undertake right now by keeping the speculative option on the table. So in short, there are fundamental concerns being raised by scientists, by countries and governments, and by civil society groups. And the proponents of research and investment in these technologies, I think, would need to acknowledge this political reality of strong scientific and political rejection. And I think these raise important questions about governance, which I'm happy to also address if of interest. Thank you.
Thank you, Aarti. Thank you very much. And what I'm going to do, so we will stay on the topic, and there's actually a lot of comments, questions on SAI in the Q&A in the chat. So I'm going to link the first question directly to what you've said, to maybe bring in a different perspective in here, and then ask you panel members individually to respond to it. We do have a question from Peter Irvine, which is very similar to many other questions we've had on SAI in particular. Peter's asking or saying stratospheric aerosol injection has risks and side effects, but did you assess how those compare to the risks of climate change that it could help offset? Martin, I'm going to start with you, if you can comment on that.
Yeah, thank you. Yes, we did pay some attention to in all of the ideas that we talk about in the paper of the influence that they will have, and in some cases, some of these ideas would have actually quite modest impacts, especially and if the climate change issue got worse and worse. But here's the thing: in all of them, we considered that decarbonising was the best way forward, and that's true at where we are now, which is under 1.5 degrees with a multi-year average. And it will also be true if, sadly, we got to 2 degrees. It would also be true if, sadly, we got to 2.5 degrees. Decarbonising is something that helps our planet, not just from the climate perspective, but also from the perspective of clean air, co-benefits, recovery of nature, all sorts of things. It's a really, really good idea, and it will happen quickly. A decarbonised world is a better world, and its effects happen really quickly, as we talked about in a Frontiers in Science paper a couple of years ago on the zero emission commitment, which I would encourage people to take a look at. So decarbonising isn't something that can be just sort of discounted and discarded, right, in favour of something else. It's something we urgently need to do, and it's our best and frankly only way to solve this problem. Thank you.
All right, thank you, Martin. I'm gonna move on. We have a lot of questions. I'm gonna try to get through as many as possible. There are quite a few on carbon dioxide removal, CDR technology, including from James Carey. The paper says the analysis does not include CDR technologies, but ocean fertilization is a CDR technology. This popped up several times. Can the authors expand on that? Valérie, maybe if you could start us off on this one.
So for the concepts that we have investigated, we have placed a focus on those that are specifically targeting the polar environment and those that have specific side effects on the polar environment. I have also seen a comment about other approaches that have been proposed to be deployed in polar regions. I have in mind the Zimov rewilding, herbivore grazing approach that has been mentioned. And we have focused on those that have, I would say, cross-boundary implications as the focus of the framework we have proposed.
Okay. All right. Yes, I saw that in the chat. That was an interesting concept that was included to be raised with you. So I'm moving on to a question by Emilia Kyung-jin, which is actually asking whether there have been any documented cases of damage from real-world geoengineering applied in the polar region. So have engineering intervention caused actual damage in the Arctic? Sophie, if you don't mind, I'll come to you first on that.
Yeah, I probably am not actually the expert to address this, but I can mention, for example, I'm aware of one of the experiments that was conducted outside of Utqiagvik in Alaska, and there were concerns there about the impacts of the silicate glass beads on the lake that the experiment was conducted on. And I understand that that project has since closed because of their assessment of ecotoxicological impacts. But I think perhaps others would have more to say on that. I'm more aware of the way in which that project did or did not engage with the indigenous peoples in that region when they were conducting the experiment.
Right, Sophie, do any of you, Valérie, Matt? Valérie is raising her hand, yes, please.
Well, what we stress in the paper is that in 2021, there was a project of a Swedish host for a Harvard-based stratospheric controlled perturbation experiment, which triggered opposition from the indigenous Arctic population, civil society, and several universities. It's also quite noticeable that the same project had initially been proposed to take place over Navarro lands in the United States. We also highlight that Mexico has banned solar geoengineering experiments following an unauthorized test conducted by a US startup, Make Sunsets, which released weather balloons containing CO2 in the atmosphere without any governmental authorization. So we stress these approaches in our assessment regarding the governance challenges.
Right, thank you, Valérie, thank you. I'm going to, so the most common, the comment that we've seen regularly now in the Q&A and the comment section refers to the research aspect. So I'm going to use Jasper Koch's question here. He puts it most succinctly and summarizes the concerns that quite a few of the people in the audience have raised. I'm confused how, on the one hand, the article states that we don't know enough yet, then advocates for stopping research. This seems like a rather unscientific position. How do you justify this for a scientific article? I saw Martin nodding, so
yeah, I can say a bit about that. So there are, of course, a lot of interesting things that will happen, and if anyone has sort of money to do research, so long as it's conducted in an ethical way, with full consideration of risks, environmental consequences, all those things that we cover, I'm sure there's lots of interesting things that will happen, and I wouldn't want to criticize anyone for winning research money as long as that research is conducted in an appropriate way. And it's true to say that if you were minded, for example, to think about ice sheet slowing, there's just so much that we need to know about subglacial environments, and for good reasons, because our models, which are really the only tools of quantifying future sea level rise, they need as much information as possible to do that. So the motivation itself to understand subglacial Antarctica is definitely there from that perspective. The question we have to ask when we're thinking about research that we want to do comes back to those 6 criteria, right? Will it work, right? How much will it cost? Is that money likely to be available? Are there governance controls? Are there environmental risks? Can you scale it? And you know what, if any one of those things isn't true or isn't likely to be true, then it won't really happen. And so you have to really consider carefully whether by pushing this idea, which realistically isn't going to happen, you're offering a sense of false hope. And I think that's what we try to characterize in our paper, not to prevent people from doing research, certainly not. But realistically, objectively, people need to take a look at these highly ambitious future ideas and see whether they meet these criteria that we set out. I think Valérie wants to say something.
Yes, please go ahead.
Yes, I would like to highlight that we have focused on this objective approach to what is a responsible approach. We have not specifically addressed what could be responsible research specifically, but I think our paper is also a call for other institutions to focus on that. For instance, in my country, in France, the French Academy of Science is considering this dimension. It's also the case for the Ethics Committee of the National Science Research Center. And I want to highlight one point. Considering research funding, considering knowledge gaps, for instance, the same point just developed by Martin also applies, for instance, for the need to advance the basic processes relating aerosols, clouds, circulation in the high atmosphere. And only when you advance this basic understanding, then you can advance the knowledge basis underpinning ideas of aerosol injection consequences. So the key question is, with limited resources for basic research, what should be responsible research pathways?
All right, thank you, Valérie. Steven, actually, yes, please. Would you mind coming in on that one?
Yes, thank you. Not to extend it too much further. I mean, obviously, research support through funding, as Martin pointed out, need not be a zero-sum game. So there could be a sudden increase in research funding. But if you think about the regions that you're operating in, there's actually a limitation to the increase and upscaling of the capability of doing this work. So you're faced by a choice with, if these are unfeasible or infeasible approaches, and you have little understanding to improve the projections for those who have to deal with loss and damage, for example, or take adaptation measures, then I think given that scaling, the most important thing you can do is actually do the fundamental work, as pointed out by Valérie, that will enable you to do that better, rather than to direct the research effort and the massive upscale in shipping, remote sensing, and the kinds of tools that are required to understand the basics of what's going on there, to do that rather than to switch it into a project that has no real prospect of delivering anything, and in particular in the short timescale available. So the timescale argument is frequently used to say, oh, we need to deploy all of this because we're running out of time. In fact, actually, the timescale argument is for us to ensure that we understand what's going on. And with decarbonization, you have the added benefit that you do away with the runaway ocean acidification that's being expected. You don't have the kinds of risks that come from nutrient deprivation of the Southern Ocean from other areas. So I think that it's pretty clear that there is an argument to be had that the research focus is there, but it has to be on what's coming and what the consequences will be of us understanding how we can look into loss, damage, and improve the ability for us to project what's coming, along with then decarbonization, which will slow down and very quickly, as Martin pointed out, what's coming.
All right. Thank you, Stephen. I reckon, Aarti, did you actually raise your hand? I think you'd probably have to.
No, thank you very much. Yeah, I think also just to comment on this question, what our academic non-use agreement initiative calls for actually is it says no public funding for all of the reasons that have been mentioned. Where should one devote one's resources, scarce public resources to? Given these criteria that were also mentioned, how feasible they are, etc., how feasible certain technologies might be, we call for no public funding for research that might lead to technology development. And I think the core question for research is really about what kind of research will actually tell us what we fundamentally want to know, which is essentially we want to know, will the risks of deploying something like SEI over a sustained period of time, will the risks outweigh the benefits, or will the benefits outweigh the risks? And to know that, essentially no amount of small scale or even large scale experimentation can potentially tell us about the planetary scale, unequally distributed future risks and regionally unequally distributed impacts of such an intervention. And I think the other panelists can also comment on this perhaps. So in short of planetary scale experimentation for a sustained period of time, which is actually akin to deployment, we need to ask ourselves the question, what will research actually tell us? And therefore, then to acknowledge the political risks of a position which says, well, let's just do the research. Of course, certain scientific uncertainties can be reduced by research. And we are certainly not suggesting, as I think was also in the chat, that there should be, even social science counts as research. I mean, all sorts of climate modeling of all kinds. We're not suggesting that there's no research of that kind to be done. But I think the question we need to ask ourselves also as scientists is whether there's a political risk of keeping this option alive by saying we're doing research, and therefore having that mitigation deterrent effect. And the other political risk is that some sort of research, small-scale or other experimentation might lead to the development of technological capabilities. And once a technology is developed, it will be deployed. History teaches us that, and nobody will ask the scientists who developed the technology whether it should be used or not. And then we get into these complex questions about if a technology exists, how will its deployment be governed?
Mm-hmm. Thank you, Aarti. Actually, yes, following on from that in terms of actual deployment and, you know, when that happens and all of that, I actually want to come back to Sophie now as well. We have quite a few questions on that as well. This one, I think, is follows on nicely here. How can indigenous people's voices be meaningful, included in any of these discussions, in these processes? And actually be part of the decision making? Are they, and how, if not, how can they become an actual part of the decision making rather than being brought on the side? Thank you.
Thank you. Yes, I think that's a critical question. The principle of, for example, of obtaining free, prior, and informed consent doesn't just mean having one meeting and getting a stamp of approval. It actually requires ongoing engagement. So for example, and maybe I can point to like an existing example. There is one experiment in Cambridge Bay in Nunavut, which is a sea ice thickening experiment, which has followed the required processes to engage with Inuit to obtain consent and to obtain the required permits administered by the Nunavut Impact Research Board. It requires initial conversations, maybe explaining a concept, exploring the concept together, deliberating together about an appropriate venue for that experiment, assessing together, informed both by Indigenous knowledge and scientific knowledge, the potential impacts and risks before any concrete experiment is carried out. As well as, I think, continuous engagement in evaluating what is happening and what the impacts are if an experiment is happening. I think it's sort of, it's quite simple, but it takes time. It's ongoing conversation. It's starting a conversation before anything is actually happening, before reaching out before you are on the ground, but also spending the time to be on the ground and engaging directly with the Indigenous community before even maybe applications for approval for an experiment are submitted. And I think also maybe notably this means engaging with Indigenous peoples through their representative bodies and organizations. It doesn't mean hiring, for example, one Inuk as a research assistant and counting that as meaningful engagement with Indigenous peoples, or even asking anecdotally one or two Inuit research assistants for their experience and perspectives on things and saying that's engaging with Indigenous knowledge. It requires working with Indigenous peoples, with their representatives who have been identified through their own processes, and having the conversations with the appropriate with those appropriate bodies. I can just mention, for example, like ICC, we're an international organization that represents Inuit on the international stage, and we are able to do that because our political makeup is empowered by the regional representative bodies within Chukotka, Alaska, Canada, and Greenland. So then at different national, regional, and local scales, there are different representative organizations and bodies that would need to be engaged with.
Thank you, Sophie. Martin, of course, come in.
Yeah, thank you, Nina, and thank you, Sophie. That's such an important intervention. I'm sure Stephen might want to add a few words to this, but from an Antarctic perspective, when it comes to projects and ensuring buy-in and appropriate governance, the earlier the better it is to engage with, firstly, the Scientific Committee on Antarctic Research, and then through the Antarctic Treaty System, through the Committee on Environmental Protection, and obtaining a permit. Retrofitting an ideal project once it's some further down the line, is always going to be less successful, I guess, than doing it from the beginning, because you can understand how to sort of co-create a project in this way to make sure that governance, environmental protection is at the heart of what you're trying to do. I know from my own experience on subglacial lake exploration, that was fundamentally from step one part of what was going to happen through the Scientific Committee on Antarctic Research. And it was far better having done that, because you understand taking everybody with you, doing something that no one ever really done before. Still a lot of work to do in that respect, is potentially environmentally, significant. And so it does need to be considered right from the beginning, and doing it later is a really bad idea. But maybe Stephen, because he's got more knowledge of the system, maybe you might add a few more words.
Yes, thank you, Martin. And that's certainly the case in each instance where a totally new idea has been presented almost as this is the project we're about to go ahead. The regulatory framework that then kicks in the debate will delay it for years and years. If, however, the work is done to socialize that initially with the science community generally so they understand it, and in turn then working with the science community that informs the policymakers that go to the Committee for Environmental Protection, which advises the Antarctic Treaty Parties, they better understand it and can communicate then the risks to the legal, policy, and other diplomatic members of the delegations that eventually have the decision-making power. And in the history of the Antarctic Treaty, most research work has not been stopped entirely when it's been put forward, but the delays are incredibly long if it's not run in the way that you've set out, Martin. And the subglacial example is a classic one, where that's been worked with the policymakers and the scientific community from the start, and in the end was able to give effect to some very clean work that was done to understand the subglacial environment, minimizing the risks. And I think that approach is one that is becoming even stronger in the Antarctic Treaty System. So as the Antarctic Treaty System is becoming used to these larger experimental and or intervention kinds of ideas, so the safeguards, obviously, they haven't changed legally, but their implementation and the thoughtfulness about them has certainly geared up several levels. And remembering that whole system works by consensus. So one party, one country that says no means that nothing can go ahead until they say yes. So it's a consensus system. Thank you.
Right. Thank you, Stephen. We have time for a couple more questions. I'll take the one from Gabriele Hegel. It's also one that covers several comments in the Q&A. Some geoengineering ideas have been proposed as emergency measures to shave the peak of warming. She wonders if the goal were framed this way, would any of your assessments change? Valérie, I was hoping, yes. Thank you.
No, thank you very much. And I would like to also address one point brought up by Jérôme Chaplas about, what would be an ethical framework for research. And I think one point that we have highlighted is on the assessment of feasibility of deployment, scaling up, which is not always considered for research on these matters. And that's one aspect on which we have tried to make the best of the available evidence, how feasible would concepts be in terms of buying time? How feasible would be concepts in terms of affordability or costs? How feasible could they be in terms of so-called emergency brakes? We've looked at some aspects from the available evidence showing that the consideration of actual deployment feasibility is really important when looking at conceptual approaches.
Thanks, Valérie. I will move on to the next question just because we're now running out of time. I do quite like this one to finish on because it's a deeper question about how geoengineering, what does it say about our relationship with nature? It's from Marc Elium. Merci. Thank you for sending us the question. The mastery of nature and progress are two concepts that have shaped scientific research. Geoengineering is the logical consequence of this legacy. How can these concepts be deconstructed and what can replace them? So, you know, much of the science has been shaped by the belief that, I guess, that humans can control nature in the name of process. Geoengineering seems to be following that logic. We're now also touching a bit on the editorial by Mike Halm. How could we rethink these ideas, and what other values might lead us to more sustainable choices, I guess? Anyone wants to take that, or Martin, actually?
Yeah, sure. I think this comes to the scale issue as much as anything, and whether it will have an effect at a sufficiently sort of large way to make a positive difference. The Arctic and the Antarctic are, as we said at the beginning, they're vast areas, and the processes operating there are, you know, have substantial power, and to think that somehow we can control them and intervene in those systems with actually what are from a human's perspective quite large structures or interventions we might want to make, but from a nature perspective actually quite small things. I really think that is debatable. I mean, I would argue that it really isn't plausible. These are colossal processes that are going on, and we should be in awe of them, and of course trying to protect them. And the better way to do that is through decarbonising. As I said, I want to go back to that question that Gabby Hagon said about, you know, shaving off the worst of climate change. Again, it comes down to a timing issue. That if you thought that was a good idea, you know, could you do it within a reasonable time to make the difference? Given that accelerating decarbonising would be, I think, a far smarter way to approach it, because of all the co-benefits that it gives you. So, you know, we're in a perilous moment, I think, on our planet. The heating is increasing. We know this. The polar regions are suffering. We know this. We do have a way forward for planetary protection and polar protection, and that is through decarbonising. And I know it might not be going as rapidly as we would wish, but it is happening, and progress is being making. And having a laser determined focus on achieving it is really surely what we must be trying to do. Thank you.
Right, thank you very much, Martin. And with that, unfortunately, we have actually run out of time for today's discussion. I knew we wouldn't even get through half of the questions, but thank you everyone who posted them. We greatly appreciate it, and apologies to all of those whose questions we have actually not been able to raise. But all we have time now for is I will ask each of the panelists to leave us with one final takeaway. We're really running out of time. 1 or 2 sentences, pithy, to the point, everyone. Thank you. Sophie, let's start with you.
Thank you. Yeah, I just wanted to assert that I think we can see that there's no single technical or technological solution that will address the climate crisis. And this is part of why we need a human rights-based approach to solve it. Inuit have the knowledge, experience, and capacity to develop and lead on climate solutions. And engaging with Inuit on climate solutions and climate action will ensure that well-meaning environmentalists do not violate the rights of Indigenous peoples on the way to addressing climate change, but it will also contribute to stronger and more effective climate action that is urgently needed, both for global well-being and for preserving Inuit livelihoods and ways of life.
Thank you, Sophie. Aarti, if I could come to you for your final statement.
Well, thank you very much. I think there was a comment in the chat about having faith in the brilliance of scientists. And I would just like to say that scientists might be brilliant, but scientists will not decide about use of a planet-altering technology once these technologies exist. And so therefore, we have to ask the crucial question about whose hand will be on that global thermostat. And in the geopolitically tense, highly unequal world that we live in. So these governance questions precede research questions, I think, and there are precedents in international law for prohibitory and restrictive regimes for activities that the world has decided are very risky and not desirable, for example, like human cloning. And we've examined all of these precedents. So I would say, yes, governance, the pressing questions of governance are absolutely vital to consider.
Right. Thank you, Aarti. Thank you very much. Stephen.
Thank you. My short reflection at the end is that we're currently busy with a gigantic geoengineering experiment called greenhouse gas emissions, and we're struggling to get on top of reversing the consequences of that experiment. I think we have the means and mechanisms to do it through decarbonization, and we have to accelerate that. But starting another set of geoengineering experiments with little governance may lead us into the same difficulties, only compounded. So we have a path forward, and we should take it, even if the path forward at the moment seems slow.
Brilliant. Thank you very much. Valérie, please, over to you for your final statement.
Thank you very much. And from the conversation, what I get is a sense of urgency that might be used to open a path for dangerous responses. That's quite striking. And I would not like to talk as a scientist, but from the basics of environmental protection. And the basis of environmental protection is that when you have human pressure on the environment, the core principle is to alleviate that pressure, reducing greenhouse gas emissions. But when considering these geoengineering options, it's really opening the possibility for more and other human pressures. So in addition to what Steve has expressed previously, I also want to highlight that in addition to acting as fast as possible and from all perspectives to reduce greenhouse gas emissions, we also need to strengthen the protection of marine areas, including in polar regions as well.
Okay, thank you, Valérie. Thank you very much. And Martin, who brought this important work to us, please, if you share your final statement.
I'll finish with a metaphor, if I may. So I'm living in wonderful Cornwall, and I'm sure many of you will know about it, maybe even visited it. And Cornwall's full of windy little country lanes. And it's definitely the case, and it's happened to me more than once, where you find yourself going down a country lane and you suddenly realize you're lost. And then another lane comes along, and there's a temptation to become unlost by taking another road, and then maybe another road. And I can say that's always a bad idea. You get further lost if you do that. The best thing you can do is to reverse out the way you came in. And that is just like the climate problem. We have got a problem because the level of CO2 in the atmosphere is 425 parts per million, and it's far too high. The way to come out of that is to reverse the damage we've done, certainly to stop it, not to take a road somewhere else that will probably lead us nowhere. Thank you.
Thank you. Thank you very much. Thank you all for your final thoughts. And thank you Martin, Stephen, Valérie, Sophie, Aarti for joining us today. I greatly appreciate it. I think it was a great discussion. It's a very important article, and I want to thank all of the audience, all of you who've joined us today for bringing us your questions, which are very important. And I hope you all enjoyed the session. Please do visit the Frontiers in Science website to read the article we've discussed and all the related content, Aarti, Sophie's policy outlooks, the editorial, etc., the viewpoint by John Moore. You can also continue the conversation on social media using the hashtag Frontiers Forum. Okay, so for now, from me, our guests, and the entire team at Frontiers in Science, we thank you, the experts, and you, the audience, for watching, for your questions. Wherever you are, have a good day, and goodbye.